In this video, we're going to work on the ALEKS problem called predicting the reactants or products of hemiacetal and acetal formation. There's a lot of different versions of this particular problem. So we're looking at one where it's given us the two reactants and it wants us to come up with two different products for the reaction. If you have a problem that is this particular format, it wants you to draw the structure of the hemiacetal first and then draw the structure of the acetal. It does have a note here that says you can assume that there are as many alcohols as you need for this reaction to work. So even though it kind of doesn't tell you that there are two of them in the problem, it says there's plenty of them in the problem. So this version of the problem wants us to draw two structures in this space down here. It wants us to draw the structure of the hemiacetal X and the structure of the acetal Y. Another version that I've seen of this problem, or I guess all the other variations of this problem, are going to have this same structure, but any one or two of these four objects could be missing. So like maybe they'll provide you with the structure of Y. It's a bad looking molecule right there. And it wants you to fill in X, or maybe they provide you with the structure of X and it wants you to come up with this guy. Or maybe they provide you with both of these, but they want you to come up with the alcohol, or they want you to come up with the ketone. Like there's a ton of different versions. The most important thing to keep in mind is that there are four different molecules in this reaction. And ALEKS is going to provide you with at least two of them. And you're going to be asked to come up with one or two of whatever is missing. So I'm going to try to keep this tutorial in such a way that it's going to work for you no matter which version of the problem that you get. I'm going to solve this exact problem, and then I'm going to talk a little bit about how you might approach it if you had a different version of the problem. So I'm going to start by redrawing the ketone that's been given to me. It could be a ketone, or you could be starting with an aldehyde, which would have a hydrogen right here. And in this reaction, in the formation of the first molecule, the hemiacetal, the way the reaction works is the carbon-oxygen double bond splits into two carbon-oxygen single bonds. So I'm going to redraw that. It splits into two carbon-oxygen single bonds. And the alcohol's carbon chain, not the OH part, but just the carbon chain, in this case it's a two carbon chain, the carbon chain gets added to one of those oxygen atoms. And it's not going to matter which one you add it to. I'll just add it to the one on the right-hand side. So I'm going to put a two carbon chain. The other oxygen just gets a plain old hydrogen. This is the hemiacetal that they're looking for in X. For the second product of this reaction, we're going to copy that whole entire molecule. For the second version of this reaction, the hydrogen is going to come off of that oxygen, and we're going to put another one of the, oh, that's so ugly. We're going to put another one of the alcohol's carbon chain, another two carbon chain on that oxygen to match the first oxygen, the first one. And this is going to be molecule Y that it is looking for. So these are the two products of this reaction. And I am going to just kind of complete this by filling everything in. So what would we do if we had a different variation of this problem? So if it was a version of the problem where it wasn't asking us to predict the products of the reaction, what would we do? For example, like what if it gave us this, this, and this, but it asked us to fill in that? Well, we could do that. That wouldn't be bad because I just showed you how to predict the two products. So what if it gave us this, and this, and this, but it didn't give us this molecule right here, and our job was to figure out what that looked like. What does that look like? The way we're going to come up with this structure, the structure of the alcohol, is that we're going to focus on the acetal group. Notice I'm going straight to the end out here. We're going to focus on the acetal group, and we know that this molecule, whatever it is, it's an alcohol, which means it has to have that OH group, and it has on the alcohol, it has a carbon chain that matches the carbon chain attached to the alcohol of the acetal. We can look at either one of those oxygens, they have a two carbon chain attached So we need a 2-carbon chain on that alcohol. That's how we would solve that. And in a problem like this particular one where we were being asked to come up with this molecule, this structure may not be provided to us because we don't need it. It's not necessary for us to come up with that alcohol structure. Another version of the problem could look like that. And our job is to figure out what this molecule is right here. So how are we going to do that? We're going to look at this guy right here. This one's going to be kind of tricky. I'm actually going to take this molecule, copy it, and we're going to work on it over here. I'm going to stick it over here. Now we know when we are making these acetals, one of the things that happens is we're starting with a carbon-oxygen double bond, and that carbon-oxygen double bond opens up into 2 carbon-oxygen single bonds, and then some stuff gets added onto the oxygen. So what we're going to do is take that stuff off the oxygen and take those 2 carbon-oxygen single bonds and close them up into 1 carbon-oxygen double bond.